the second challenge, visualize this quadratic function. So from the challenge, you can see is we did this in chapter 1 for this kind of the quadratic equation. We put this x value and then to calculate y value. So, and y is just the x squared 2 plus 2x plus 1, and we put a list of the x and calculate y through our for loop and make that print out. These challenges, we will do the visualization of such kind of the calculation. So let's starting in our doing this. So first, let's change this. Yeah, we can put that as the 1. So 1, and we create 0, 2, 0, 5, 2 with the visualize quadratic function .py. Let's see what the expectation. So your program challenge is to enhance this program to create a graph of the function. Try using at least the 10 value for x instead of the 6. We can use more. So calculate the corresponding y using the function and then create a graph. Once you create the graph, spend more time analyzing how the value of y varies with the respect of x. Is this linear or non-linear? So that is we will see that later. So let's create this. So visualize. Let's see. So we will see how this we will do this. Visualize function. So let's starting to have our first is we need to more and more the familiar with this import with py plot as plt, and we have our code, and let's make the basic the draw graph. We just have xy, so you remember it's just we put this plot xy. And then this plot plt.show. So that is our basic one. And then we put the main part is here. So if name equal to min, then what we will do to consider. So what you will do is we assume first is to list down the x. So let's put our value. So x values equal to our range. So range is we put that is from the negative 100 to 100. If we want the 10 value, we have 20. So that is step is 20. Then we have the 10 values. Then what's the y? Y first is we put that as our empty list. Then is we do through the for loop to assign the calculated y to this list. So for xy in range, we don't need the y. So in x in range x value. So what we will do is to calculate that is y value. Y value is dot append. And those is we have the calculation. So if you want to calculate other function, you just need to change the this here. So then through that is we have two lists. And these two lists is matching in pair each other. Then we just call here is the x value and the y value. I think it's that should be simple like this. Let's run this. Yeah. So type range is not a subscript. So the range. So yeah, you see the issue is I use this. there is a square brackets, but actually for range, I should use this parentheses. Oh, that's nice. Is and we don't have this 100 you see here. So 1, 2. So we have this. The last one is the 75. So that is from the days. Let's see. So we have. Let's put that to 120. To have this, yeah, that is now is balanced. So just we gave the 11 list and they retrieve those first 10. So if I put that in more the steps, then you will see is that will be quite the kind of those smooth. But those I think is we should have this 102. So you can see here now it's getting the similar the way, but it's getting smooth. And you can see here is like what we did. We drop our stone to the sky. Is then it's just the vice versa. So that is the thing. So if I try to put something different, for example, I maybe change this the signal. Then for every part you can draw something. So maybe I not is plus. Then let's see. Yeah, that is this way, and if I put here is minus, then you can see the difference. It's getting from another angle. If I put this to 100, then you can see the difference is they will have a certain the shift to the different way. So and if I put this, I want to see the 3 powered by 3, then that will be different. So you can now is depending on your function. So maybe it's I add 4x times x 2, and then minus this one. So let's see. Yeah, you have this smooth still. So if I put that in the even higher, then you can see you can create the different the shape of the functions. So that is useful for you is if you are putting something here. So let's see the if we are putting the function equal to this one, and we have these are. So we need to make this here. And then we just call this our function. So let's make this lower. So you can see here. So that is the way is now we build this function as our the variable. So if you want to change the definition of this function, you can get the different the lines. And then this we can see is function 1 is the this one. So y value, so y values 1. So let's see. So y1 value is the function 1, and y2 value. So let's see. So if you want to put two functions to the compare, I keep is making this expanded. So let's see function 1, function 2. So now is we have this y1 value, and we will make another part is to y2 value. And then let's build the function 2. So if I put this just like let's back to our function. So x2 plus 2 times x plus 1. And another one is let's see. So we have minus. So let's see. and this function 2. So now we should have 2 lines. Okay, let me see. So y2 function value here. So what's this take 2 position argument, but 4 were given. Let me see here. So I will draw this one. Oh, yeah, so plot. Yeah, so and x1, 1, x2, y2. So I will have this 1, 1, x2, y2. So now you have your plotting part is also. So now you have 2 lines. So depending on this, let's make the another is plotting. The PLT legend. Legend is one is the function function 1, but I think it's we also need to define this one. So function 1. Let's see. So it's better we put that into the, let me see, so x and let's put y equal to function 2. It's not good enough because I have hard coding 2 parts. But I just wanted to put is now you learn this which line is on the which function. So at least this I want to show you is you can expand this a little bit, then you get some more the colorful and useful drawing to do the comparison of 2 functions from now on. So thank you for your watching. Next video is we will go to third challenge, enhance the projectile trajectory comparison program. So we will use that stone throwing the program to do some enhancement. See you then.